This is video 5.2c. We're looking at the application of some trigonometric functions in right triangles. Specifically, first we'll talk about angles of elevation. Think of an angle of elevation as like your line of sight, or basically the angle from a flat surface, for example, the ground, up to the top of something. And so you're always going to have this angle right here, and that's going to give us information. Looking at our first example, a fire started at a campsite located 8 miles from the base of a mountain. If the angle of elevation from the fire to the top of the mountain is 14 degrees, how high is the mountain? So first of all, to draw a little picture, or at least draw a triangle, we've got a fire here, and we've got the base of the mountain over here, okay? And then we know that that distance is 8 miles. They did tell us that. And then we know that there is an angle up to the top, and we don't know that distance, but we know the angle is 14 degrees. And this side over here is how high is the mountain, which we could call x, okay? So in this case, I've got my base angle right down here, and so the 8 miles would be the adjacent side, and the x would be the opposite side. We're not using the hypotenuse in this case because this would be our right angle. Excuse me. So we need to find the tangent of 14 degrees, which is opposite, which is x over 8. So in this case, it's a pretty simple process. We're just going to do 8 times the tangent of 14. You've got your calculator, and you end up finding that x equals 2 miles. Okay, so let's look at one more of this type of example. Actually, the next one is very similar, but I will give you a heads up. You don't know the angle. You know two sides of the triangle, and you need to find the angle, but we learned in the previous lesson about inverse trig functions, and so I'm just going to give you a hint that that's what you're going to do. And if you're not sure, go back and look at 5.2b at your inverse trig functions, and that should help. And the reason I want to do that is because some of these are a little bit more difficult to set up. So let's, for example, look at number 4. Lana's kite is flying 60 feet above the ground. The angle of elevation from where her hand is holding the string to the top of the kite is 48 degrees and 18 minutes. If her hand is 5 feet from the ground, find the length of the string. So the reason this is important is because notice that the angle of elevation is from her hand holding the string. So it's not going from the ground, it's going from her hand. So we have this total height. So like here's the ground, okay? And going all the way up to the kite, we have 60 feet, okay? That's the total from the ground to the kite. But then we are told that the hand is 5 feet from the ground. So her hand is actually here. This 5 feet is not included in the angle, okay? So when we get her actual triangle, notice over here, if I were to include the whole height, that would extend the length of the line because the hypotenuse is going to be longer because the height is higher. That's why it's important that we make sure that we're noting that the 5 feet has to be taken out, and the angle, oops, sorry about that, the angle is actually this right here is the 48 degrees and 18 minutes, and this is the length of the string, okay? So we're going to do 60 minus 5 to get the total height, and we need to change the 18 minutes into degrees, and so I'm just going to go ahead and tell you that it becomes 48.3 degrees, and that equals, since we're using sine here because this is our angle, I've got the opposite over hypotenuse. So I've got 55 feet over x because I don't know what the hypotenuse is, and it's 55 because I had to subtract out the 5 feet between the ground and her hand. And so in order to solve this, using our algebra to rearrange this problem, I get that x equals 55 divided by the sine of 48.3, which will come out to 73.7 feet. Okay, so your job is to do number 2 and 3. Let's look at 5 and 6. 5 is pretty straightforward also, nothing tricky there, so I'm going to let you work that one out. Number 6, I don't want to just do it for you just because it might seem difficult, but I will talk you through the setup real quick. Sarah is standing 35 feet from the base of a rock wall, watching her 2 sons, Max and John, climb the wall. The angle of elevation is 38 degrees to Max and 27 degrees to John. How many feet above John is Max? So basically, if you think about it, we know her angle of elevation to each child, and we know where she's standing, so that's going to be the same. So Sarah is standing here looking up at her 2 sons, okay? And then she's standing a certain distance from the base. And it's completely possible that my lines are not, I'm not trying to draw this to scale, I'm just trying to get a visual of what's happening, okay? So I've got Max, who is at 38 degrees, and John at 27. Okay, so we've got 2 different angles. This one for John is the smaller one at 27 degrees. And this one for Max is the bigger one at 38 degrees. Both of these I can calculate because I know, I can calculate the height for both children because I know that she is 35 feet from the base of the rock wall. So all I have to do is find the height for Max and the height for John, which would be the opposite, because we're not using the hypotenuse in this case, but we've got the adjacent side and we need the opposite side for both of them, and then you can just subtract the difference between their heights because we want to know how many feet above John is Max. So like how much higher is Max. So now that we've set it up, I'm going to let you go ahead and work on finishing that yourself. Number 7, building A is 464 feet tall and building B is 321 feet tall. Dale is standing between the buildings. The angle of elevation from the point on the ground where Dale is standing is 75 degrees to the top of building A and 48 degrees to the top of building B. How far apart are the buildings? So again, I don't want to work this out for you entirely, but I want to help you get started. So let's imagine that over here on this side, we've got a tall building, okay? And then we've got this little man standing in the middle. And on this side, building A, we know the height is 464 feet. On the other side, I've got building B, which is a little bit shorter. This is building B, and it's 321 feet, okay? Now, I'm also told the angle of elevation from where Dale is standing. And notice it says the angle of elevation from the point on the ground where Dale is standing. So we're not having to worry about how tall is Dale and figure out his eye level subtracted from the building or whatever. It says from the ground. So that means for building B, I've got this line here. And that angle is going to be 48 degrees. And for building A, I've got a similarly dotted line, and that angle is 75 degrees. Now, honestly, there's no rhyme or reason why I'm drawing a dotted line except for that since I'm making a picture here with people and buildings, there's not really a line at the line of elevation. You can just draw triangles if you want. But so this is what we're looking for, but the key fact is to remember you need to know this distance and you need to know the blue one. And then the question is how far apart are the buildings? So let's just bring in another color. We want to know the total distance. So I've got 2 angles. I have their opposite sides. I'm looking for their adjacent sides, and then I need to add them together. I think that you can do that math on your own, so give it a try. And then let's talk about the other type of application problem we have going here. These are angles of depression. So looking at the diagram, let me first just remind you of some key details. This is imagining like this is the line of sight that's in a dotted line right here. There's a dotted line, that's your line of sight. And that is basically considered to be parallel to the ground. okay, because your line of sight would be measured straight and flat, and so would the ground. And so remember, if the angle of depression is the angle from your eye line looking down, but these are parallel lines, this side of the triangle would actually be a transversal. And if you remember what you learned about transversal lines, the angle of depression here would be congruent to this angle. They're the same because it's a transversal cutting parallel lines, and those are alternate interior angles. So going to number 8, from the top of the lighthouse, 150 feet above sea level, the angle of depression to a boat at sea is 28 degrees. What is the horizontal distance from the boat to the base of the lighthouse? So we can draw ourselves a picture. We have this little lighthouse. It's 150 feet tall. And then we have a boat at sea. It's 28 degrees. So here's our line of sight parallel to the ground here. And we've got this angle coming out like this. Now remember, originally we said that the angle of depression would be here is 28 degrees. But then we noted that means this side is also 28 degrees, okay? And what we are looking at is, what is the horizontal distance from the boat to the base of the lighthouse? That would be here. Because remember, our boat is right over here. So we're looking for x. We've got 28 degrees. We have the opposite side at 150 feet, and we're looking for the adjacent side at x. So we've got opposite and adjacent, which means we've got to use tangent. And so you're doing the tangent of 28 equals 150 over x. I'm going to let you work that out now that we've set up the drawing. For number 9, pretty much the same process, but don't forget to change the degrees into just degrees in decimal form instead of degree minute second form. And then on number 10, also pretty much the same. And number 11, yeah, a lot of these are the same, but let's jump down to number 12 real quick. A scuba diver spots a shipwreck at an angle of depression of 26 degrees. The angle of elevation from the scuba diver up to his boat is 53 degrees. If the shipwreck is located directly below his boat and the horizontal distance between the scuba diver and the shipwreck is 120 feet, find the vertical distance between the shipwreck and the boat. Okay, so here's the boat up here on the water, and here's the shipwreck way down here underneath, okay? But it said directly underneath. And then we've got this scuba diver. He's sort of in the middle, right? Not exactly, because the angles aren't even. But we know that his distance between the scuba diver and the shipwreck is 120 feet. And the key thing to notice is it says horizontal distance. So we don't have to worry about that being a slanted line. So this distance, oh, sorry, I forgot I was using the highlighter. So this distance right here to the diver is the 120 feet, okay? And then we know that he's got an angle here from the diver to the shipwreck. We know that that side is there, and it's got a 26-degree angle, okay? And then from the diver to the boat, we use a different color here. We've got this, he's looking up at the boat, and we know that that angle is 53 degrees. I'm going to have to write it outside. I didn't write big enough. Okay, so we have all of this information, and we've got multiple things going on here. This would be the height to the boat from the diver, and down below we would have the height to the shipwreck. And what they actually asked us is, what is the vertical distance between the shipwreck and the boat? So they want this whole thing. I'm going to call it T for total. So we need to add the distance from the diver to the boat, vertical distance, and the vertical distance from the diver to the shipwreck in order to get the total. We can see here we've got two triangles. On both triangles we have one side. We have the side adjacent to the angle. We don't need to worry about the hypotenuse. We've got to find the opposite sides and then add them together. So you're dealing with opposite and adjacent, and so that will be tangent. And I am going to leave it to you to find out the answer.